I welcome you to the video on very interesting topic. How should faculty execute research and development R&D at innovation-led industry-driven university? I am Professor Jitesh Thakkar, Dean Academics and Professor Logistics and Supply Chain Management at Gati Shakti Vishwavidyalaya. When we say industry-driven, innovation-led university, it intends to execute, carry out the projects in mission mode, the project which are important for the mandate of the nation, and typically in Indian context, the project which contributes towards Atmanirbhar Bharat. This requires a very unique approach. It's a project-based approach, interdisciplinary approach, and the R&D projects are typically executed in bottom-up manner. So let us see first what is this bottom-up approach, how it really benefits, and how we can expedite R&D, collaborate with industry, collaborate with government, and really deliver the meaningful research and development output which can strengthen the nation. So there are a couple of important points. Number one, when I say project mode research, bottom-up research, then number one, it originates at the grassroots. So this approach starts with the problem statement, with the individual faculty, team of faculty and students, research team. They identify the specific, often national mission or in line with the localized problem, and then they try to develop the solution, process, or technology for this mission critical problem. Problem driven, number two, is problem driven and specialized. In bottom up approach, project oriented university, typically called industry driven innovation led, execute the R&D project which is defined by a solution to be highly relevant and tailored to a specific industry need. That means you want to optimize, let us say, a single manufacturing process, design a product which meets the requirement specification of a particular industry, or develop a technology which is directly in line with the national objectives. Number three, encourages prototyping and experimentation. So when you are executing R&D in project mode, it is inherently experimental and iterative. No fixed solution is ready-made available. You can certainly refer the literature specific to the particular problem or project, but you have to customize the solution, tailor-made the solution. So this encourages prototyping and experimentation and typically prioritizes the rapid development of proofs of concepts and small-scale prototypes before seeking large-scale institutional funding or approval. Number four, facilitates industry trust and partnership. We always say there is a gap between academia and industry. So if a university operates with the bottom-up approach, project-oriented approach, and R&D, this gap between industry and academia can significantly be minimized. So starting with a small, successful problem-solving pilot project for a local industry, partners builds trust and confidence, and subsequently this serves as the basis for undertaking the large-scale project, more comprehensive sponsored R&D contracts. Number five, this contrasts with the top-down mandates Unlike the top-down approaches mandated by institutional strategy, the bottom-up method empowers researchers and ensures that the project portfolio remains agile, diverse, and directly responsive to evolving technological and industrial requirements. It's not just about having few publications or coming out with the research paper. It's more about creating the impact and how we can address the real life problem, benefit the nation towards Atmanirbhar Bharat and the society at large. And this is something where bottom up approach is absolutely unique and need of the hour. Let us look at some of the very, very important dimensions when we talk about innovation-led industry-driven university and contributing towards nation's mission through project-oriented bottom-up approach. Number one, innovation-led industry-driven research for Atmanirbhar Bharat is the need of the hour. This shifts demand that research priorities align with national economic and social goal. The output must contribute directly to self-sufficiency and strategic capabilities. I would be happy to share some of the benchmark examples across the globe to motivate the team and really undertake the real life project which has direct impact for the nation and society. So benchmark example here could be USA and MIT. You can see the MIT Lincoln Laboratory operates as a federally funded research and development center. Typically, we call it as FFRDC. And its mission is to apply advanced technology to problems of national security. It perfectly exemplifies university-led research driven by strategic national needs, ensuring that US maintains technological self-sufficiency in critical domains. Number two, when we talk about project-oriented R&D bottom-up approach, the number 2 point is solving real-life complex problems of India. The focus is on macro-level societal challenges that requires deep applied research rather than incremental academic advancement. In the Indian context, this means clean water, decentralized energy, and affordable healthcare solutions, and many more. We can see the benchmark example UK, Imperial College London, the Gretham Institute, Climate Change and Environment, tackles complex, multifaceted problems like urban air quality, sustainable energy transition, and their research is benchmarked against UN Sustainable Development Goals, SDGs, making their research inherently complex but valuable for society. Number 3, define end user or industry partner. So you have the deployable research. Research cannot be executed in isolation. That is the mantra of this era. It must be co-created through interdisciplinarity, through collaboration with the industry, ministries, government. And this typically sets the pitch for highly conducive R&D development for industry, NGO, and government. This guarantees relevance and ensures the path from lab to market is integrated right at the design stage from day one. We can see the example from Singapore and US. The National University of Singapore and US actively pushes for faculty involvement in startups, industry spin-offs, and their licensing agreements often mandate an industry partner for commercialization, ensuring research like advanced materials or biotech solutions is immediately deployed in the Asian market. So your design R&D to market can drastically be minimized when the research is done in the bottom-up approach, project-oriented, mission mode approach. Number 4, transition output, prototypes, patents, and viable products. So the core matrix shifts from impact factor, which we have followed so far, number of publications and the citations it receives. Here, the focus is shifted from impact factor of a journal to the transition rate. And when I say transition rate, how quickly the IP is commercialized, patented, or adopted. So tangible output is the focus, and the market, society need specific deliverables is the expectation. We can see the benchmark example, USA Stanford University. Stanford Office of Technology Licenses, OTL, is world famous, and they didn't just publish on the foundational work for recombinant DNA technology, they patented it and licensed it widely, generating billions in revenue and creating the modern biotech industry. This demonstrates the power of IP in bottom-up approach over simply having research publications. Number 5, project-based R&D, culture and professional structure. This is very important. You cannot operate in bottom-up research organization, innovation-led industry-driven university unless you set the right culture. So project-based R&D, culture and professional structure is very, very important. So adopting an agile, risk absorbing culture and approach really supports project-oriented bottom-up approach for developing R&D at the university. So here what is important is the budget resources, deadlines, mandatory technical readiness level, and gateways mirroring the corporate R&D cycle and so on. So previously we used to operate with waterfall model in projects. Today, waterfall model is not very much relevant. When the technological advancements are significantly rapid, we go with the agile project management approach. We can look at the benchmark example, Germany Technical University and Fraunhofer. German Technical University work very closely with the Fraunhofer Society, which operates entirely on contract research for industry and government. Research is structured as formal paid projects with clear TRL conditions, progression, and mandatory deliverables, institutionalizing project-based R&D. So we talked about 5 important dimensions which really cultivates the culture for industry-driven, innovation-led university and sets the pitch for fast deliverables needed by the government, society, and the market. Let us look at a couple of more dimensions. Number 6 is multidisciplinary team. Most important, break silos. Do not create the university which is tight bound within the departments. That will really kill the culture of innovation. Today's projects are highly complex and absolutely it is not within the purview of an individual to deliver amicable solutions, desired solutions at single level. You need cross-functional team, you need interdisciplinary team, and this is something where you can even look at the concept of smart city. This cannot be solved by a single department or faculty, and it requires active engagement across different disciplines like computer science, civil engineering, public policy and management, and so on. We can look at the benchmark example where we can appreciate the multidisciplinary team approach for bottom-up research and R&D. So, University of Michigan, the Michigan Mobility Transformation Center, MTC, is an interdisciplinary project focused on connected and automated vehicles. It brings together engineering, urban planning, law, and social science faculty pulled from various programs, departments, schools, and create a holistic interdisciplinary team to address and solve the problems in urban mobility. Number 7, student integration as junior research fellow, project staff. Absolutely, you need the resource when you have to solve the real life problem in the project oriented manner. And here, even we can see some of the institutions which has operated in this mode, IITs and ISCs and even Gati Shakti Vishwavidyalaya. We are operating in the same industry-driven innovation-led mode where we hire the project staff dedicatedly required, possessing the competence to execute a real-life project, and this sets the pitch for delivering the amicable solutions in the most, say, limited time window of R&D. Number 8, identifying an industry niche and problem-solving proposals. See, in this bottom-up approach, project-oriented R&D, you cannot expect the problems to be available just like that. You have to interact with the industry and really dig out what is their requirement, and many times even your clients is not very clear what are their requirements. So you have to have series of dialogue to understand the expectations of each other. So faculty must become consultants. Instead of waiting for funding calls, they must proactively study a company's pain points, whether it is energy consumption, supply chain inefficiency, and propose a targeted research solution. We can see the benchmark example, South Korea KIST, that is the Korea Advanced Institute of Science and Technology. This institute's mandate specifically industry engagement, quotas for many tenured faculty, encouraging them to identify and solve high value problems for major Korean conglomerates like Samsung or Hyundai. Point number 9, protecting IP and generating licensing revenue. Typically, we call it as TTO utilization. So university must view its intellectual property as an asset. Faculty must partner with the TTO to file provisional and full patents before publishing, maximizing the economic potential and providing an alternative revenue stream for the university. University down the line has to see that in what way they have their own fund generating mechanism through publications, through product development, through consultancy services, and so on. The benchmark example here is Israel, Harbu University of Jerusalem's Yisam. So here, this university's technology transfer company has commercialized thousands of inventions, including successful drugs, agriculture technologies, and their success hinges on actively managing the IP portfolio and aggressively seeking licensing deals globally, showing the financial power of IP. Last, but the important point, point number 10, when you talk about the bottom-up approach, project-oriented R&D at university, and typically innovation-led, industry-driven university, how do we set the culture and execute the projects? So point number 10, proactive networking and with industry professionals. If we live in silos, we would never understand what are the pain points and what are the expectations of the industry. So it is extremely important to participate in different industry relevant events and interact with them, really to get the picture of reality and what exactly they are expecting. So research begins with a handshake, not a literature review. This is very, very important point. When you talk about bottom-up approach, project-oriented approach, research begins with a handshake, not a literature review. So maybe it is little bit, say, hardening for the traditional researcher, but yes, we have to be adapted to the emerging requirements of the nation, Atmanirbhar Bharat, and see that in what way we can transform our university culture, typically in terms of R&D, to go ahead in a proactive manner and address the real problem of the nation and industry. So faculty must dedicate time to attend industry events, serving on corporate advisory boards, and developing personal relationship with CEOs, R&D heads to unearth the potential projects. So here it's quite iterative. Projects will not come to your platter just like that. Benchmark example is USA, Georgia Tech. Georgia Tech places a strong emphasis on industry liaison. They run major industry consortiums and frequent networking events, actively creating spaces where faculty and corporates, industry R&D teams, managers can meet to scout potential collaborative projects rather than just inviting industry for placements and career fairs. So I hope this 10-point elaboration would help you to appreciate what exactly it means when we say that how faculty should execute research and development R&D at innovation-led industry-driven university. What are the prima facies? What are the prerequisites? What are the cultural settings? What is the mindset? And what kind of proactiveness which is expected at the end of the faculty and their team, which is highly interdisciplinary to address the real life problems for Atmanirbhar Bharat and Atmanirbhar industry segment. Thank you very much for your interest in understanding the new era of R&D, innovation-led, industry-driven university, and our responsibility towards nation, Atmanirbhar Bharat, and the society. Thanks.